Hello, this is assignment 8.2, problem number 8. This is where someone is bending over holding a weight, and we're trying to find out how much tension is in the back muscles and how much compression is in the spine. I have drawn a bar to represent the body. The pivot point is here, and we can consider the weight of the body acting in the middle of the bar. Here we have the muscles in the back pulling at 12 degrees, and then out here we have the weight of the object. The weight of the object is 220 newtons. The weight of the body is 290 newtons, and the tension is what we're looking for. It says the tension is 2/3 of the way over from the pivot point. We don't really need to know the distance. We can just use the ratios, and so we could say this is 0.67 meters, and this is 1 meter, and this is 0.5 meters. We could also say this is 10 meters, this is 6.7 meters, and this is 5 meters. It doesn't matter as long as the ratio between these three numbers stays the same. So we're not even going to put meters in there, we're just going to use these numbers as the ratios. Then I've taken this triangle right here and I've drawn it larger over here. So we have the tension of the back muscles, we have the perpendicular force, which we are going to calculate first by using our torques in static equilibrium. And then this component of the tension represents the compressional force. So first we're going to find the perpendicular force, and then we're going to solve for the tension in the back muscles. So the torque net is going to be equal to 0 because it's in static equilibrium. So that means the sum of all the torques has to equal 0. So we take the torque of the body plus the torque of the perpendicular tension force plus the torque due to the object. So then we have a negative 390, and that's negative because it's causing clockwise torque, times 0.5 meters plus the perpendicular component of the tension force times 0.67 minus 220 newtons, and again it's negative because the weight of the object is also causing clockwise torque. So it's a negative 220 newtons times 1. And that ends up giving us 240 newtons for the clockwise torque. And we're going to add that to both sides, so it ends up being positive. So right here, we have our equation for the sum of the torques. And then when I add these two numbers to both sides of the equation, I get 240 newtons. And I still have the 0.67 perpendicular component of the tension here. And so then I divide both sides by 0.67, I end up with 359 newtons. Then to find the tension, I'm going to just use trigonometry. And the tension is the hypotenuse, so it'll be the perpendicular force divided by sine theta, which will be 359 newtons divided by sine 12 degrees, which gives us 1,730 newtons, or 1.73 kilonewtons. And then for the compression on the spine, we're going to use tangent. And you'll see that we end up with the perpendicular force divided by tangent 12 degrees equals 359 newtons divided by tangent 12 degrees, which gives us 1,690 newtons, or 1.69 kilonewtons.